Greetings everyone. I am Vishal Deo and I'm going to talk about the basics of R today, and the topic is Introduction to R in my lecture. And in this lecture I'll be covering um, these topics. First I'll be giving a brief background of R and where to get the software and getting familiar with the environment of R and RStudio, and then I'll move on to talk about some basic but very useful functions and operations in R. And then we'll start with the R objects, where the first kind of object will be vectors. We'll see how to define vectors, how to use vectors for computations, and how to index elements of vectors, and so on. So let's start with the topics. So first let us see what is R. So for those who are beginners, who are trying to get into the R environment and learn how to use R, these things are going to be very important. So R is basically a high level programming language, and which is specially designed for computations, statistical computations and graphics. And it is something very similar to an earlier package called S. In fact, it has been inspired by S. And our software was initially developed by Ross Ilaka. Language was developed by Ross Ilaka and Robert Gentleman, and both were at the Department of Statistics, University of Auckland, New Zealand. Later on, various leading statisticians and software engineers joined the core team for developing R, and that included John Chambers, who was behind the development of software S as well. And now it has become a very collaborative effort of leading statisticians across the world, and various packages have been incorporated in our on day-to-day basis, and all these packages are being incorporated through research work by various statisticians across the world. And we should also understand why R is important, why actually so many statisticians across the world are using R, and why it can be helpful to us as well. So first of all, it is a freely available software, and there are other prominent statistical packages like SAS and SPSS, but they are very expensive, and individuals cannot afford them. So it is first of all freely available. Secondly, it has a very wide coverage of statistical methods. Almost everything we can think about in statistical techniques or modeling or any kind of testing, everything is available in R through various packages, specialized packages. And also, like as I said, that most of the statisticians across the world right now are using R for their research, and because of that it is very up to date, and latest packages are coming, and even the latest techniques which are being developed in statistics are being incorporated in R. So it gives us a lot of flexibility, a lot of options through dedicated packages of R. Also, because of that, because so many people are already engaged with her, because of that, sorry, it's playing, yeah, because of that, it is a highly reliable language. The results are accepted by all the journals, and it gives you a lot of reliability in your results. And lastly, I'd like to say that it also has extensive support and manuals available freely on the web, so you can just search on web or even on the archive of R, which is available on CRAN, and you can get a lot of support. So once you have a good foundation in R, once you understand the environment of R, it will be very easy to keep learning, to keep extending your knowledge in our language. So what is CRAN? CRAN is basically comprehensive archive network. So it is the library where you get everything. First, if you're using R for the first time, you can go to the cran.rproject.org website and download the latest version of R, which is available according to your operating system. It is available for Linux, for Mac, for you know uh, for Windows and all kinds of operating softwares. So download it from there, and you can find various manuals, packages, journals available on the same website, which will help you to get started with R. Now, one option is to use our software directly, but the user interface is not very user friendly. So I generally prefer to use RStudio as the integrated development environment which supports R. So it is basically the platform where I run R, because I use RStudio because it is very flexible, and the whole user interface is very friendly. And so we'll be using this RStudio in our lectures, and I'll also suggest you, those who are starting to use R, they can also use RStudio. So this software is also available for free on the website rstudio.com. At least the basic version is free. Right? So let's get familiar with how to work on R. So before going any further, I'll just show how the R language window looks like, and then we'll also have a look at the RStudio and see what is the difference and why do I prefer RStudio, and then we'll define various sections which are available there. So just a moment. Okay, so this is how the R interface looks like. It is, this window is called the R console, and here is a red prompt which is called the command prompt, where you write the command and execute it. So suppose there is a function called get wd, which is for getting information about the working directory. WD is for working directory. So if you want to know what is the current working directory, so working directory is basically the directory in which the files will be saved, or if you are trying to find any file for opening here, that is the first directory where R will look. So if I just enter the commands and press enter here, you'll get the output which gives you the path of the current working directory, which is by default in the C drive right now. But suppose I want to change this working directory, that also we can do that. We'll see there is another command which says set wd, that is, we can set our own working directory. So we'll see that. So this is how the R console looks like, and then you can save the file. You can go to file, and there is concept of script files as well, where you can type your commands, like you are typing on a notepad. It acts like a notepad. Here you will not be executing the command directly. Instead, you can write commands which you write in a notepad and then run it from here. So there is option for running it. So you can just select the command, or just go to the line where the command is written, and you can press on run this selection. So see, again, when I went there to the script file and selected run, the same command has been run, the same output has been generated, right? So it is better when you're writing a longer program, not just a statement, you're writing a program, a code. So it is better to write it in R editor called the script file, and from there, because it is much easier to type there, and instead of running line by line in the console, you can run the whole program together through R script, or you can run a selection of commands from R script. So all that we'll see in detail later on when we start working on it. So you can save the script files, you can save, you see this option saving, you can save the workspace here. So saving workspace means whatever variables you have defined, whatever values have been generated, everything will be saved, right? So this is how R looks like. Now if you go to RStudio, so first suppose you, if you have to use RStudio, then first we have to install, download and install the latest R package, and then go to the RStudio website, download the RStudio and install it, so it will automatically connect to the R language which has been installed in your computer. So here the user interface looks something like this, which is, you can customize as well, but we will not go into detail right now. So suppose when we open the RStudio, it looks something like this. There are various windows here. The first window here, which says untitled right now, is actually the script file we just saw. So here you type your commands. This is the script file. You can save the script file from here directly, or you can go to file and save as, or save from here. And the lower one, and this, you can change the size of the windows as well. So this one, this here is your console, R console, which we just saw. And on the right hand side there are more windows. You can change the sizes here. So here you'll get information about the environment. The environment right now is empty because I have not run any command. So when we define any variables, save output, so all those information is available in the environment. And the history will show you the history of commands which has been executed. So all commands which have been executed in a session will be shown here, the history. If you want to erase the history, you can use this broom here, broom sign, click on it. It says, are you sure you want to clear all history entries? Click on yes. You see, now it has been cleared. So similar for environment also, if you want to clear the variables which have been saved, you can click on this broom sign, broom button, and it will clear the workspace as well. So this environment is nothing but the workspace. Sometimes what happens that suppose you have run a program and all the values which have been saved in the variables, you want them to be saved all together, not just the commands but the output as well to be saved. Then you have to save the entire environment, that is the entire workspace, and you have to save the workspace from here, this button. So everything is in front of the eyes, and that makes RStudio much more flexible and much more user friendly to use. If we generate any plots or graphs, in the fourth window here you can see there is option for plots. You will see the plots saved here, and then from here you can export your plots as well. So everything will be trying with examples. So let's see. So this is how RStudio looks like, right? And moving on now, so we have seen how what the environment looks like, what is our console. Working directory we'll discuss in detail again. So suppose I'll just tell you one thing. Suppose I want to see what is the current directory we are working on. Working directory, so either you can type the commands here in the console. If it's a single statement, you want a quick answer, you can just type it here, enter, you'll get okay, this is the path of our current working directory. That means if I'm saving any environment, any files, that will be saved in this folder, documents folder in the C drive. But suppose I want to change it, so I can use set wd directory. So when I type any command in RStudio, another very important feature, very useful feature is that it gives suggestions. It gives suggestions about the function. So even if you're not remembering the exact name of the function, it will give suggestion and you can select it from it. So the function I want to use is setW, which is for setting the working directory, and you see as soon as I have written set w, it has given me suggestions of the functions which start with these keywords, and the first one is set w, which I actually want to use. So you can go there and select it, and you can also see that there's a brief uh, hint or a help about the function which is there. It says set w, and then inside bracket as argument you have to give the directory name. So it returns an absolute file path representing the current working directory. That is get wd, and set wd is used to set the working directory. So that information, so this becomes very useful while doing any programming, especially when you are starting with R. So that's why that's another added advantage of RStudio. So set wd, I want to set a particular folder as my working directory. So inside these two brackets, small brackets, I have to give the path name, right? So if you remember the path name, suppose I want to set it to D drive, and a folder called, say, I'm not remembering the folder name, let me check. Yeah, this is the folder I want to use, suppose R presentations in the D drive. So I'll just, you can write R presentations, right? So when I run it, now you see the command has been executed, and now if I check what is my working directory, so for that I can type get wd. Again, now it's, you see the working directory has been changed to the path which I just entered. So working directory is important because, as I said, when we are going to save environments and save the workspace, they get saved in the working directory. So that's why it is a good practice to change the working directory to the folder where you are saving all the files related to the work you are doing. Uh, So we have seen what script file is. Basically, script file is a kind of notepad where we can type all the commands and then execute it directly from there instead of typing it in the R console. And then the output are, you see the output comes in the R console. But if you want to export those output as well, there are various ways, and we'll be talking about that in other lectures. And there are various packages available in R. Some of the packages you see are installed right away when you install the R software, and the information about packages you can see, you can click on packages on this window. So it shows all the packages which are available in the library of R. So some packages are by default present, like there is something called base package. As the name suggests, it is always there. These are some of the packages which are already there, and then as users we can install various other packages which are meant for specific purposes. For example, if we want to conduct experiments on survival analysis, so there is a package called survival. Various packages are like thousands of packages are available, and as per our utility we can download those packages and install from CRAN. So that is something we can do. So information about the installed packages can be obtained here. Another way of getting the names or the list of packages which are installed in R is to type the command here as well. So you can type the command installed dot, you see, as soon as I type the command install, it is giving me suggestion that whether I want to use this function. Yes, I want to use this function. So install that packages. Once I do that, in this console you get the output, you get the list of all the packages including their versions on which they are built. You see all those packages, the list of packages can be shown here. Anyways, so this is something I wanted to show. So that gives a lot of flexibility to using R, because there are so many packages and we can choose our packages according to our needs and install them and use them while running R. So the base packages which are available with R, when we install them, they are already there in the library. But if we want another packages, we can download them, and we have to uh, combine them or in the library when we use them. So we'll see that later on. Now, running a command we have seen, saving workspace we have talked about briefly. Now let's start working on that is the best way to learn R. That is the best way to remember how to use R when you do it on your own. Hands-on practice is important. So first, let's start with the basic things. How to get help in R, because that is what we'll need if we are learning R on ourselves. So there is one command, one way is to use the question mark sign. So if you want to get any help on a inbuilt function, for example, there is a function called mean, or there was function which we use, say, get WD right now. Sorry. Get WD. So if you want to get help on this function, how to use this function or examples on this function, sorry, it is creating issues. Anyway, so just write a question mark and execute this command, right? And if we want, there are some reserved words which are used for programming. For example, for is used in looping. So if you want to find help on this reserved word, you have to type question mark first. Sorry, here I used wrong. You have to type the question mark first and then the name of the function. So type the question mark first, and within double quotes you have to write the reserved word. Right? Similarly, another function available is help function, which gives you help on the inbuilt functions. So you can write help and then the name of the function, say mean or get WD, and then for getting help on any reserved word, again you have to use double quotes inside help. So let's see how it works. So suppose I want to get help on set WD or get WD. So I'll write question mark get WD and enter, and you can see on the right hand side the R documentation opens up, and it gives a very comprehensive overview of the function getWD, right? In fact, it will give the R documentation will talk about all the related functions as well. So there is getWD and then there is setWD. So it will also give you some examples. It will first tell you about the arguments which have to be passed, and then it will also give you examples of how to use these functions. So this is a very useful function to get help. And similarly, you can use the help function. So if I use the help function here, let's see what is the difference in the output. Get WD. Again, you see the same output comes on the right hand side, the same R documentation comes. So both can be used interchangeably. So this is about getting help. Another way to get help, suppose you don't remember the exact name of the function and still you want to search for help. So you don't remember the exact name, but you remember some purpose of the function. So say we wanted help on working directory. So we don't remember the name getWD or setWD, but we know that that function was related to working directory. So these are the keywords which you can use for searching such functions. So you can search help.search and write the keywords inside double quotes, and writing that inside double quotes will search for the closest functions which have a function related to these keywords, right? So that you can do. Now again, now let's see, if you know a function but you are not sure which package contains that function, so for that you can use the function find. You can write find and the name of the function. So suppose I want to see where is the function getWt, in which package is it stored, in which library it is there. So if you want to find that, you can write this. So let's see. So find getWt. So it directly shows the answer which says package name is base. So as I told you, there is a base package which contains all the important basic functions of R. So it is there in the base package. The function getWt is present in the base package. Similarly, if you want to see where is the function mean, which calculates average arithmetic mean actually. So if I want to see where is that function, you can find again that function is there in the base package, right? So you can find the package where the any particular function is saved. And to see working examples of inbuilt functions, again this is very helpful. I keep on using it because sometimes you forget what arguments you have to pass, or what arguments you have to pass in which order. So you can get help through examples, very elaborate examples are given. So there is a function called LM which is for linear models. Or suppose even if you want to find examples on mean, so what you can do, you can simply use this function example and type mean inside it. You see the examples of using mean function has been given to you. So you will get different kinds of examples. So this gives you a very good idea of how to use functions, right? So all these functions are such that you need them again and again while using R. Now the first thing, how to define variable names in R, or basically what not to do while defining variable names in R. So there are three important things which you have to remember, which is very similar to the name rules for other packages as well, for other languages as well. First of all, variable names in R are case sensitive. That means if I'm defining a variable with name X, capital X, or I'm defining a variable with name small x, both will be treated as different variables in R because our variable names are case sensitive. Secondly, variable names should not begin with a number or a symbol. I cannot write 1x. This is not going to be treated as a variable name. Similarly, you cannot use any special symbol to start with for a variable name. And very important, you should not leave any blank space. That is not acceptable in R. So if you want to write a variable name, say roll number, so don't leave a space. This is not right. You can use as a good practice, you can use underscore, or you can use dot, right? Or you can simply leave any space and write roll number. And it is always a good practice to use smaller, shorter names for variable and something which you can identify with, right? Now, yeah, so basic operators which are available in R. So first is arithmetic operators available for arithmetic operations. So there is addition, subtraction, and this one is star mark is for multiplication. This forward slash is for division. This percentage slash percentage gives you the integer quotient when we're dividing some number with another. And this gives you the modulo. This double percent is the modulo function. This symbol is used for power. So these are some basic arithmetic operations available in R. Relational operators, so greater than, this one is greater than, equal to, less than equal to. This double equal to is used when we are checking relation whether two values are equal or not. Yeah. If we use single value, it will be used as an assignment operator. It will assign a value to the given variable. But if I'm writing double equal to, it means I'm checking whether the two values are equal or not. And this exclamation mark equal to means not equals. Exclamation, basically in the next logical you can see exclamation means not. So here also exclamation and then equal to means not equal to. Logical operators, not, this is not, this is and this one is or. Right? Model formula. Now whenever we are defining suppose we are defining a linear regression model where y depends on, say, x1 and x2. So we can write it as y depends on x1 plus x2. It means we are defining y as a dependent variable, x1, x2 as independent variables. So we will see that later. An assignment operator. So the basic assignment operator is this, right? So if I write x5, that means I am assigning the value 5 to the variable x. Another alternative is to simply use equal to. This is also acceptable in R. So you either use this symbol as assignment operator or you can use 5. List indexing, we will talk about that in detail when we talk about list or data frames. So this will be used a lot of times. And creating sequence, so this colon sign is used for creating sequence. Again, we'll be discussing this symbol when we discuss vectors. So yeah, so now it's time to start with R objects. So these are the basic units which we use in data handling in R. So there are basically 4 types of objects in R: vectors, arrays and matrices, lists, and data frames. These are the 4 class of R objects which are available to us. And we'll start with the basic one, vectors, which may be basic, but it is very useful. Once we understand how R works on vectors, we'll understand how it works on arrays, lists, and data frames as well. So in this lecture, we'll start with vectors. So what are vectors? So vector is a variable or object with ordered collection of elements of same time. These two are very important. Ordered collection of elements of same time. So when we say same time, this means a vector can either contain numeric values. So all values should be numeric. If we are talking about a character vector, then all the values it has should be of character type, and so on. So all the elements of a vector should be of the same type, and the elements are ordered collection. That means if I'm writing a vector as x equal to, say, 1, 2, 4, 6, 7, or say y equal to 2, 5, 1, 2, 3. So these two are vectors where each element are of same time, that is they are numeric in nature, and also it is a collection of such numeric values, and thirdly it is ordered collection. Or by order it means position. So the position of the elements is also important. So here for vector y, you see the first position is occupied by 2, the second position is occupied by 5, third is occupied by 1, fourth by 2, and fifth by 3. So position is very important when we are going to use indexing. So basically we say that the first element of y is 2, second is 5. Even if we use the same set of elements, but we write in a different order, then this vector is not same. These two are not same. y and z are not same because the order of the elements has changed. So order is also important. So order collection of elements of the same type is called a vector. So either it can be numeric vector, or like this, it can be a character vector as well. Now how to define vectors in R? So like if I want to assign a single value to a variable in R, I'll just write, okay, I use the assignment operator and say x equal to 5. So or I can say alternatively x equal to 5. So this will assign a value 5 to the variable x. Suppose I want to define a variable, define a vector. So how to do that? So there is a function called concatenate function C that can be used for creating vector. So if I'm using concatenate function, it basically does what? It combines all the values which are written inside this function and creates a vector. Right? So I can write, for example, here if I write this, it will create a vector x having elements 1, 2, 3, 4, 5. If I write C, so suppose let's try this on R. So I'll create a new script file just to show you. So file, new file, R script. So a new script file has been opened. You can save it with a name if you want. So suppose I want to create a new vector called x using concatenate function C, having values say 2, 5, 6, 8, 1, 4. So there are 6 values, 6 elements in this vector. I have not executed this command yet. So if you execute this command, so how to execute it? You can place your cursor here and there is a sign run the current line or selection. So you can simply press on this, or the shortcut key is Control plus Enter, or even Alt plus Enter helps. So I have just placed it here and press Control plus Enter, and the command is executed. Or you can simply place your cursor here and just press this button, run. It will be run. You see in the console it has been executed. Now if you want to see what values are saved in x, you can simply go to the console, type x and press enter. You see it shows the values which are saved in x are 2, 5, 6, 8, 1, 4. Remember this in the output, this square bracket, the number written inside the square bracket just shows you the line number of the output. So the output is there in only one single line, and the output is 2, 5, 6, 8, 1, 4. So the x is, we have created a vector x which has elements 2, 5, 6, 8, 1 and 4, right? And similarly, if I want to create a character vector, say a, the difference is we can use the concatenate function, but now I have to write the characters either inside double quotes or single quotes. Both will work. So either I can write, say, A, B. Now you can use some names, say, Amrit, Jack, David, right? So if I want to execute this, either you have to select and run, or you can just place your cursor. If you want to run a single line, place your cursor here, press on run. You see it has been executed. Now if you want to see what values are saved in A, just type A, enter. It says Amrit, Jack and David. Double quote show that these are character type values. You can check the environment here. Now since we have defined various variables, we have executed certain commands. So you see, you go to history, you will see all the history of all the commands which we have executed right now. And if you go to environment, that is the workspace, it shows you the value, the objects which you have defined. So A, X, and it also gives you the values which are saved in these objects. So that's important, right? And an alternative way would have been, suppose I want to create character with the C, you could have simply used a single quotes as well. That will create, right? So you can run it and see it has been executed. There is no error. Type C, and it again says that C is a vector, and it shows it in double quotes. So while typing, you can either use double quotes or single quotes to define character values. So this is how we can use concatenate function to create numeric vectors. But what happens is, suppose you have to create a very large vector, say of sequence, then how to save time? So suppose you want to generate numeric sequences to create vectors. There we can make use of the operator, colon operator. Right? So here we'll definitely use the concatenate function, and when we write 1 colon 10, this simply refers to 2. So it says we are creating a sequence, a vector of sequence of numeric values from 1 to 10. So basically it will create y as a vector 1, 2, 3, 4, 5, 6 up to 10. So even if I write 1 to 100 in just one short command, it will create a vector y of 100 elements with values from 1, 2, 3 up to 100. So suppose you want to create roll numbers. Their roll number is in sequence. So instead of typing 1, 2, 3, 4 till 100, you will save time by simply writing, okay, roll number is equal to C 1 to 100. Right, so it will save time. So this colon is used for creating sequence. Right? Now suppose you want to create a sequence, but you want to use a increment value. So you want, suppose we want all the odd numbers to be saved in a particular vector. So say if I give this command, so there is a function called sequence. Seq is for sequence. So we write sequence, and then the first argument which we have to pass is the starting point. So either you can write from equal to 1, or you can simply write 1. But you have to remember the order in which you have to put the argument. So first argument says from where, so that is the first starting point, then 2, say 100, and the third argument is for increment, by how much you want to increment. So if I give by as 1, that simply means it will create the same vector as this one, 1, 2, 3, 4 up to 100. But if I'm writing sequence 1 to 100 by 2, this means it will create sequence like 1 plus 2, 3 plus 2, 5, 7, and so on. So it will create a sequence of odd numbers between 1 to 100. So that's why sequence function is also very useful. So let's see how it helps. So suppose I want to create a sequence odd of odd numbers between 1. So I'll use sequence function seq. Inside I write 1 to say 100, and I want to increment it by 2. Just run it here. It has been executed. Now you want to find the value. You want to see the value which is saved in odd. You see, these are the values which has. So now you see, for the first time we have output which is there in multiple lines. So here actually now I remember I told you it is the line number. It is not the line number but the value number. So the first, it starts from the first value here. So, and the 18th value starts from the second line. So 35 is the 18th value, and the 35th value starts in the third line. So 69 is the 35th value. So all our odd numbers, odd integers, are generated by this sequence command, and it is saved in the vector odd. Okay, so another way of generating sequences is when we want to repeat certain values. So suppose you want to create a vector where of size 10 of, that is, it has 10 elements, but each element is equal to 1. So this REP is for repeat, it is repeat function. So when we write R equal to repeat 1 comma 10, that means the first value is the value of the elements, and the second is the number of times it will be repeated. So it will create a vector simply of 10 values of 1. So this will be the output which will be created. But we can also use this kind of command. So in the first place, this is the value which will be repeated. This is the number of times it will be repeated. So but here the value which will be repeated is not a single value, but it is a vector itself. C1 to 3, it's a vector itself. So this sequence will be repeated. So 1, 2, 3 will be repeated 5 times. So again 1, 2, 3, again 1, 2, 3, and so on till 5 times. So 5 into 3, that is 15, will be the size of this vector R, right? And then if I write this command like this, that means this is the vector which will be repeated, and this is the vector which gives number of times the corresponding elements will be repeated. So when I write this command, it means 1 will be repeated 2 times. After that, 2 will be repeated 3 times, and after that 3 will be repeated 2 times. So let's see how it works. So one is to simply write, say, R1, we're using repeat function, REP, say we want to repeat 2 5 times. I will not execute it, I'll just show how to execute multiple lines together. R2, suppose I want to show repeat, I want to repeat a vector, say 1 to 5. Now we can use 1 to 5, we know what is the usage of colon sign. And comma, we want to repeat this sequence, how many times we want to repeat it, say 2 times. And thirdly, suppose I want to define a vector R3 where I want a sequence C, say 2, 3, 5 to be repeated, say I want 2 to be repeated thrice, 3 to be repeated thrice, and 5 to be repeated twice, suppose. So I want to execute all these 3 commands together. So what you can do is you can select all these 3 commands and then you can click on run. So this, all the selected commands will be executed at once. You see in the console you can see all the 3 commands have been executed together. And now if you want to see what is saved in R, type R1. You see 2 has been repeated 5 times. What's in R2? Let's see. 1 to 5 sequence has been repeated twice. So 1, 2, 3, 4, 5, and again 1, 2, 3, 4, 5. And what about R3? You see 2 has been repeated thrice, and then 3 has been repeated thrice, and then 5 has been repeated twice. So this is another way. These functions are useful in various circumstances as per our need. All right. There is one added advantage of using repeat function. Sequence and colon sign, these can be used only for creating numeric sequence, but repeat can be used for character values as well. So if I define a vector character vector R and give this command, so it will create a character vector of 10 elements where each element will be equal to So repeat can be used to create a sequence of character vectors as well. Now there are many functions, inbuilt functions in our packages, in base package as well, which can be applied directly on vectors, and that's why these functions are called vectorized functions. So many inbuilt functions in R are vectorized. That is, they can be used on the entire vector directly without the need to create a loop. Right? So we can try I have listed some. Obviously, this is not exhaustive list, but you can try this function. So if I write, suppose x is a vector, if I'm writing sum of x, so it will add all the values which are there in x. Mean of x, again it will return the arithmetic mean of all the values. Minimum of x will return the minimum among all the elements of x, and so on. Similarly, maximum, variance, range, rank, sort. Now sort is something different which we should see. So let's see, let's try it here. So we already have various vectors. Let's try to apply this function on one or two of them. So suppose we had created a vector called odd, which is a sequence of odd numbers from 1 to 100. So suppose I want to find the sum of all values from 1 to 100. Right, so you can simply apply sum in bracket. You just write the name of the vector, odd, and run this. So it gives the sum is 2500. Right? Similarly, if you wanted to find out mean, you can write the command here, or you can write the command in the console and run it, because we are running one by one only. So mean function, so mean of odd, it gives 50. So 50 is the arithmetic mean of the value stored in odd vector, and so on. Now let's have a look at any vector which is not ordered in any sense, because the odd vector, this one is ordered in ascending order. But suppose we look at this vector x, it is not in ascending or descending order, and we want to sort it in ascending or descending order. So we can use the function sort. If I'm using the function sort here, say sort x, and you can, whenever we are applying any function, we can save the value in another variable or another vector as well. So suppose we are sorting x, so the answer will again be a vector. We want to suppose save it in vector y, so we can write it like this: y sort x. So let's see what happens. If I execute this command, I get, let's see what is the value of y now. So y contains all the elements of x, you can see 1, 2, 4, 5, 6, 8, but now it is in ascending order. It has been sorted in ascending order. That means if I use the function sort, by default it sorts in ascending order, but suppose we want to sort in descending order. So actually there is another argument in sort which is descending equal to. So whether descending is equal to true or false. By default, descending is equal to false. And if you want to actually do sorting in descending order, then we have to write descending equal to true. True has to be written in capital letters. Right? And let's see what happens if we execute it now. Oh, sorry. Decreasing, not descending. It says you have to use decreasing. In fact, I don't have to write it as well. Let's see. So I run it. Now if I see y, the same elements are there, but now in descending order. Now the good thing is that we don't have to write decreasing every now and then. If you remember that the second argument is for whether decreasing is true or false, by default it is false, then you can simply write the command as sort x comma true. True has to be in capital letters. So you run it, and you see the value of y, you see that you get the same output. And even better, even better is you can simply write capital T instead of writing the whole true. Just write capital T, it will signify the same thing. So if you run it, you see it has been executed, and if you find the value of y, the same value is there. So the shortest command will be this one. So once you know that what argument has to be passed in the function, you can use it here. And again, if you don't remember, you can get help on that function. Suppose I want to get help on sort, question mark sort, run it here in this window. Wait, yeah, in this window you get help on sort. So it says decreasing equal to false. That means by default it is false. If you want to use descending order, then you have to write true. And you will find examples as well towards the end. You see various examples have been given. Right. So all these functions you should try. There are various other functions as well. Now we can also apply various mathematical functions and arithmetic operators to vectors like log. So the difference is now if x is a vector, and suppose x is a vector 1, 3, 5, and if I apply the function log of x, what will it give? It will give me a vector again. It will generate a vector with values log 1, log 3, and log 5. Similarly with other functions, mathematical functions like exponential. Exponential x will give us a vector. It will return a vector with values e to the power 1, e to the power 3, e to the power 5, and so on. Right? So this ABS function is for absolute value. It will return absolute value of again return a vector with absolute values of the elements. Ceiling function actually returns smallest integer greater than x. Round function is used for rounding to certain digits. So all those you can try. So good thing is that all these functions, they are applicable on single values also. So if x is a single value, if y is a single value variable 5, log y will give you log 5. Otherwise you can apply directly on vectors as well. So it will automatically apply to each and every element of the vector. And then there are arithmetic operators, plus, minus. This will give us summation of two vectors, minus will give us, so it will give us element-wise summation. Element-wise summation, we'll see what it means. This is element-wise multiplication. That is, corresponding elements will get multiplied. But this is something different. It is called matrix multiplication, used for matrix multiplication, or called the dot product of vectors. So we'll see what is the difference here. So it is more useful when we are using matrices, which we'll be dealing with in the in lectures later on. So suppose now, I have two vectors x and y. I have created y as sorted value, so both are of same size. Suppose I simply want to write x plus y. So let's see what happens. So it adds the corresponding elements of x and y. If we just show you what was x, you see 2 plus 8, 2 plus 8, 10, 6 plus 5, 11, 5 plus 6, 11, 4 plus 8, 12, 2 plus 1, 3, and 1 plus 4, that is 5. So it adds, that's why I wrote element-wise addition. So corresponding elements are added. Similarly, x minus y will subtract corresponding elements and generate a vector. And what happens if I write x multiplied by, that is star y. So it again gives us a vector where the corresponding elements are multiplied. So it gives us 16 first value, that is 2 into 8, you see, 2 into 8, 16, then 6 into 5, 30, and so on. Then how is it different from the other sign which we call as matrix multiplication? So x percentage star percentage 1. You see, it returns a single value, and it actually returns it in the form of matrix. That's why it says one row and one column. So we'll understand it better when we are going to use matrices. But here the difference is now 114 is the addition of all these values. So it is called dot product of vectors, those who are familiar with mathematics. So dot product of vectors. So for that this is used. This is how it is different from simply using star. Okay. So basically if we have two matrices, we want to multiply them, then we have to use this operator percentage star percentage. Anyway, so all these operations are available, and it depends on the need and practice how much you remember them. And then a very important part in programming is indexing. That's very important. It's very important to learn them. So what does indexing mean? Indexing means extracting elements of a vector using subscripts. So suppose, what does extracting mean? Suppose x is this vector, but I want to see what is stored in a particular position, of x. Suppose I want to see what is stored in the second position of x. So in this, I'll write x, then I'll use square bracket, and then I'll write 2. So it will return 13. It will return 13 because when I write square bracket, it means I'm trying to recall the value which is saved in the second position of x. Now remember one thing, that indexing in x starts from 1, that is position numbers start from 1. 1, 2, 3, 4, 5, 6, 7, 8. Why is it important? Because in certain languages like C, indexing starts from 0 instead. But here it starts from 1, so there is no confusion. So similarly, what will be x5? x5 will be equal to this value, 16. So this square bracket is used for indexing or extracting elements of a vector, right? So instead, if you want to extract, instead of just one value, suppose you want to extract second, third, and fourth value together. So we can write x, and then we can use the sequence operator. So it means basically we are extracting, this is equivalent to saying that I am going to extract 2, 3, and 4. So it will give us a vector of size 3, where the elements will be 13, 14, and 15. So 13, 14, 15. Right? And suppose you don't want to extract a sequence of this, but instead you want to extract different positions. So you want to extract what is there in the first position, what is there in the fifth position, what is there in the seventh position. So just use a vector of positions inside square bracket. So square bracket, inside we use a vector of positions. That means it is going to return the values which are saved at the first, fifth, and seventh positions. So concatenate function again comes handy, very handy. So these things are very interesting, and you'll get used to it when you practice. Practice is very important. So it will return us what? It will return the vector first element, that is 12, fifth element, that is 16, and the seventh element is 14. So this is how indexing is done. So let's run it and see. So we have an element, a vector odd. You remember that's a large vector, and if we want to see what is saved at, say, 35th place, so 69, value number 69, you can verify why I have written 35, because when we, you can verify it from here. But you see the 35th position is 69, so it has returned 69. So similarly, suppose I want to see what values are saved at, say, I use concatenate function, say 36th value, 39th value, 36th value, 39th value, and say 41st value. So it returns three values, 71, which is 36, and 77, which is 39, and 41 value is 81. So it returns these. So this is very useful because sometimes, suppose a vector of sequences, suppose you have, say, marks of students, and you want to see what is the marks of the 20th student having roll number 20. So you can simply use this indexing to get the marks of that particular student. So that's a very basic example, but in other ways also it is very useful while doing programming. Indexing is very useful. So these are different ways of indexing. Just remember that we have to use square bracket, because in certain other packages, like in other programming languages, like in MATLAB, we use small braces instead of capital braces. So even I get confused when I switch between R and MATLAB. So remember, in R we use square brackets, capital brackets for indexing. And some more, some more ideas are there. So suppose you, instead of extracting, you want to exclude certain elements. So before that, what we are doing, we were including certain elements. We were saying that we want to include first, fifth, and seventh elements in the vector. So we were including. Now if you want to exclude certain elements from a vector, so you can use a negative sign for that. So we call them negative indices. So if I write something like this, x minus, and then in sequence 2 to 4, that means the second, third, and fourth elements of the vector x will be excluded, and the output will be the remaining values in that vector x. Right? So suppose some student has dropped out and you want to exclude that from the result, so you can use negative index there. So negative is for exclusion, and it will return all the other values except those values which you have entered here. So again, you can use the concatenate function also. You want to exclude the first, fifth, and seventh value, so rest of the values will be shown. So let's try this. Interesting. So in order, suppose we now know what are the values, say that 36, 9, and 41st position. So suppose we want to exclude them. So I can write, okay, odd minus C 36, 39, and 41. So now you see the 36 value was 71, it has been removed. The next value was 77, that has also been removed. 81, that has also been removed from the result. So it's very interesting. Again, we can use logical commands to extract values. So suppose we want to extract all those values from a vector x where x, the value is less than 15. So basically we want to extract all those elements which are less than 15, or maybe which are greater than certain value. So these logical operators can be used for that purpose. So when I write this means I want to extract all those values from the vector x which are less than 15. So let's see in the odd. So if I write odd, suppose I want to extract all those values which are greater than 90, say 90. You see, 91 to 99, 91, 93, 95, 97, 99. So it's very convenient. So similarly, you can apply various conditions inside these two square brackets to extract values. So you can try different things. These are only some of the examples, definitely not exhaustive. Now, while doing computations in R, this is something which we always face. Sometimes our result is shown as infinity or NaN, and what does it mean? You should know. So basically, whenever the output comes like this, INF, it represents infinity. Means something you should understand that okay, some problem has occurred where something has been divided by zero, right? And NaN is basically not a number, represents not a number, and it is basically not defined. In mathematics sense, we say not defined. For example, 0 by 0 is not defined. So if in calculation somewhere the results are such that 0 gets divided by 0, then it will return NaN. So it will return NaN, that is not a number, not defined. And then Na is again very important. Na represents missing values. So if you have missing value anywhere, it will be represented by Na in R, right? So, and to see if there is any missing value in a vector, we can use the function is.na. So we are asking R, is there any missing observation in this vector? So is that na? Why? So it returns true or false. So what happens, suppose if I define a vector C where there is a missing value in it. So it has the third element is missing here. So if I apply the function is.na on y, then this is the output I will get. First one is not missing, so it will return false. Second one is also not missing, so it will return false. But the third element is missing, so it will return true. That is, there is a missing value here. The third element is missing. The fourth element is not missing. The fifth element is not missing. So this is what it returns. And then also for extracting or indexing, we can use this function is.na. Suppose you want to have only those values, return only those values which are not missing. So you can write y and square bracket for indexing. So is.na returns values true for values which are missing. But for indexing, we want true for values which are not missing. Do you understand? Is.na returns value true for values which are missing. But we want to return true for values which are not missing. So you can use the logical command not here before is.na. So whenever there is true, not will convert it to false. And whenever there is false, not will convert it to true. So when I write is.na y, so what happens is it will be is.na will return this vector, and then we have applied not before it. That means false will be converted to true, this will become true, this will become true, this will become false, this will become true, this will become true. And then y, when we say y of this vector true, true, false, true, true, so it will return only those values where there is true. So it will return 1, 2, 5, 8. This is again a very nice and interesting way of returning values in presence of missing values. So missing, these three are actually very important. Whenever we are doing any computations in R, we will always go through missing value problem, always go through the problem of infinity or NaN. That's very common, right? So just know what it means. You see, if there is infinity, you understand that something is being divided by 0. If NaN means 0 by 0 form is coming. And if you have missing values, then you can use is.na to find if there is any missing value inside a vector. So suppose, let's try after missing all this. Suppose I define a vector z, concatenate, I write 1, 5, 3, and then I just don't enter anything in between and write 6. Argument 4 is empty. It says argument 4 is empty. Why? Because we have not specified it as a missing value. So what we can do is one more thing. If you use up arrow, you know, the previous commands will show up, you see, using up arrows. So if you want to make changes to previous commands, instead of typing the command completely, you can just press up arrow and then make the changes here. So suppose I write NA here. So now the Z vector is defined. You can check what are the values. So NA means missing value, and you know, so if I want to see if there is any missing value in Z, is dot NA and then Z. So it returns logical output, false, 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 true and false. So true wherever there is a missing value. So if I use not is dot NA, suppose again I'll just source the previous command and then write not, then you see not makes everything opposite. So false becomes true and true becomes false. So now if I want to extract only those values which are not missing, then I can write okay, Z not is dot NA Z. You see 1, 5, 3 and 6, NA has been removed. So it's very interesting and very useful as well. And regarding NA, we also have to understand that there are certain functions. If we use those functions on a vector which has missing values, then it will not return answer. You will face problem in which. So what to do in that case? Suppose we just saw how to use mean function. We had used it earlier, sum and mean functions. So suppose the vector we had just defined has NA, and that is the missing value, one or more missing values in it. So if we use it inside a function mean, then it will return the answer as NA, and that is a problem. That means it is not returning the desired answer. So what we want is suppose we want to return the mean of all the elements which are not missing. So then for that we have to pass another argument inside the mean function where we say na.rm is equal to true. na.rm can be read as na.removed. So it says that we want to find the mean of the values contained in y after removing the missing values, and then it will return the answer. So sometimes people forget that there can be missing values in a vector in the data because the data is generally huge. So we have to be careful that we have to see if there are missing values, and then we have to alter our commands accordingly, right? So again, we can use complete true, or we can simply use capital T for true. So na.rm is a very important argument for such functions, right? So in this vector z, suppose I apply the function mean. See, it gives value z, it is not returning value. Let's see what happens if I am applying z, even sum of z, even sum is not giving us answer. So we can apply okay, mean of z, and then write na.rm, rm for removed, equal to true. That means yes, we want to remove the missing values, and then we are getting the answer, and this answer is nothing but the mean of the remaining values, that is after removing the missing values. Similarly, we can apply it to sum as well. Sum z comma na.rm is equal to true. It gives us sum of the value as 15. So this is also important, right? Suppose we want to replace the missing values by certain values. Say we want to replace by 0. Sometimes it happens that while collecting data, when the value is 0, people instead of writing 0, they just keep it as a missing value. So if we want to replace it by 0, so you have to first identify the places where there is missing value, and then at those places we are going to assign the value, say 0, right? So this is what we are doing. is.nay, we have seen that it identifies the places which has 0 in it. Basically, it returns true for places, not 0, sorry, it returns true for places where there is missing value. So all such places, so all such indexes where missing is true, we want to assign the value 0. This is what we want to do. So in Z, we want to see where are the missing values, and those values we want to replace. We want to assign 0 or any other number. You can assign any other number. Here we want to replace it by 0. So now if I want to see Z, you can see the fourth element was NA. Now it has been replaced by 0. So that's the importance of indexing. It helps us a lot. You can apply a lot of logical functions inside indexing. You can give various conditions where we want to do indexing. So thank you. This was all I wanted to discuss in this lecture, and furthermore we'll be discussing other objects in R and how to import export data, and then we'll move on with other statistical techniques, how to apply them on our data.